table. One person from each table. Come get a sticky note. You need a sticky note for everybody at your table, though. For our if statement today, our if statement is the maximum speed of the giraffe is 32 miles per hour. So at the top, what I want you to write, giraffe and then greater than 32 miles an hour. So a giraffe is greater than 32 miles per hour. Okay, and then down along the side, you're going to write lion, cheetah, cat, man, and pig. I'll leave it up on the board for a minute. So lion, cheetah, cat, man, and pig. Yeah, domestic cat. A domestic cat is like a cat that you would have in your house.
Can you put that?
Just an average man. So it's just for man, it's just going to be average man. Yep. Average man. Okay, so now you're going to take a guess. They're all 2-digit numbers. There's no 3-digit numbers for each of these. You want to guess how fast they, like their maximum speed is. So individually by yourselves, what you want to do is you want to guess what your maximum speed is for each one. So guess the speed for lion, cheetah, cat, man, and pig. You can work with the table. Okay. But it should be done quietly though. Work with the table quietly.
I'm gonna do this. I think it's 8, 12. Yeah, 15. A man, I'm pretty sure, who like Usain Bolt can run like 20.
Remember the first thing is they're all 2-digit numbers.
50?
First thing is all 2-digit numbers.
Yeah, no, Usain Bolt can. I heard it on television. Yeah, he can run as fast as
An average, no faster than 61. No way.
Okay, so you want to just take a guess. I'm thinking more guess.
Okay, no Olympic. Yeah,
but he's Usain Bolt. Average 80, 10 miles.
No, average is 17. Let's do 18. Let's do 18. No, 18. Because I can run. 18.
Okay, and class.
Yes.
Okay, the next thing. What do you think about? I'm going to give you one more hint. 2 of the animals have a greater speed than the giraffe, while 3 have a lesser speed. So 2 of the animals have a greater speed, and 3 of them have a lesser speed than the giraffe. Remember, the giraffe is 32 miles per hour.
Cat's like
3 of the animals.
about like
For cat, about, I said 12. Yeah.
2 of them.
Oh, 15. 15.
no, like 16. 16.
I've seen them. Alright, 16. 16. I say, you said man could run 60 miles an hour. There's no way.
2 have greater than the giraffe, and 3 have less.
Okay.
Alright, so we
Hi,
have
Mr. Harry.
cheetah and lion.
Take him.
Yes.
Are you all in agreement on your answers?
Yeah. Yes.
Do you have 2 that are greater and 3 that are less?
I'm going to get to that in a minute.
What do you think the fastest animal is?
Cheetah. Easily. Cheetah's the fastest animal that we know. I heard that cheetahs run like.
Did you have to adjust your estimates at all?
Oh, yeah,
A little bit?
Yeah, a little. Yeah. But no, we didn't have to erase it.
Yeah. But Vernon, Usain Bolt actually has a pet cheetah.
You should do that. No, a speedboat. Yeah, I would say.
And class. Yes. Okay. In computational, the sum of the speeds is 189. The sum of the speeds is 189. Remember, that's not the giraffe. That's for the 5 that you have written down. 189 is the sum. The sum of the speeds is 189.
We got 150.
So remember, if you're below 189 or greater than 189, you should adjust your speeds.
You guys are talking.
Yeah, 25. No, because that's like
189.
No, yeah, I forgot. Nah, I think 20. Let's change. What? How much?
189.
Oh, 189. I thought it was 160.
189.
45.
So remember, that's the 5, not the giraffe, too.
No. Let's change lion to 52.
Wait, what's 52?
Lion. Let's change it to 52. 10 more.
Yeah.
So our cat is 19 miles per hour. Lion, 52. Cheetah is still at 60. No, I know.
No, I'm trying.
We are, change to lion.
No, 189 is correct.
No, we're 117. Like, I know. I got 146. So, we're 17 off. I got 172. Yeah, that's what you got. Oh. Guys, we're 17 off.
She has like 70.
Yeah.
Okay. Okay. So now, let's see how we did. Okay, so lion is going to be first. Lion is going to be first. So lion is, the answer is half of 100. Half of 100. So the line is 50, half of 100. Okay, now the cheetah. 30 less than 10 squared. 30 less, remember, 30 less than 10 squared for the cheetah.
Yes.
Okay, the cat, remember it was a domestic cat. 6 more than 2 dozen. 6 more than 2 dozen.
So we never said it. We said 16.
The more I think about it, the more I might be wrong about if it's a house cat. That's too fast for a house cat. I would never have guessed that. Close to me.
I'm thinking
Okay. the next one is a man. So this is a tricky one. So listen to the words. Number of days in February on a non-leap year. So the number of days in February on a non-leap year. Okay, that was the maximum speed. I actually told you maximum speed. I'll take that one on me. If you guys got that one wrong, that's on me because I told you average for the man. So think of Usain Bolt. Think of Usain Bolt.
Oh yeah, you say roll over right.
Dude might add, he might play in the NFL. Yeah. Okay, pigs. Okay, one more than the basis of our number system. One more than the basis of our number system. So it's 10 plus 1 is 11. Hey, Mr. Herrick, are we keeping on those and hanging on those for the rest of the week?
Total up on the price.
Okay. So keep your points. Okay, class.
Yes.
Okay. Oh wait, eyes on me. Okay, so tally up your points. And then we're going to tally them up and we're going to keep them. We're going to score them until Friday, okay? So tally them up and add them to what you have so far.
Wait, Mr. Backwards.
Yes.
We started doing this.
Wait, do we keep our points from Monday?
Yeah, from the whole
Yeah,
week.
but we
So add them up.
switched on that.
Oh, Monday, no. Tuesday on. Your new team.
So we only have 1 point.
So now we should have our interactive notebooks out. So go ahead and get your interactive notebooks out, and then you have interactive notes in your black container on your desk. Okay, so keep those out. We're not going to do anything with them yet. I'm going to read you a little story. So remember our friend Elma, Ima. Our friend Ima, right? Ima's not so smart. But we're going to test her out today. Ima has 2 friends. Their names are just as silly almost. Thelma and Joe. Ima, Thelma, and Joe. Okay, they want to have a party with you guys. So you gotta listen. Okay, so it says Ima, Thelma, and Joe are going to have a pumpkin carving contest with all of their friends from BCI. So that's you guys and all of 5th grade. So Bell Creek has a lot of students, so they will have to buy over 200 pumpkins. They plan on traveling to 23 pumpkin patches to gather all of their pumpkins for the party. They buy 25 pumpkins at each pumpkin patch. How many pumpkins total will Ima, Thelma, and Joe buy from the pumpkin patches? And then will it be enough for all 200 students at the pumpkin carving party? Okay, so we're gonna look at this in 3 different ways. Okay, so on your paper, on your notes, I want you to first let's cut them out, and then we're gonna put them on the what side do you put them on in your notebook? Left side. Okay, so you're gonna cut out on the lines. I put a little line around everything. So you're gonna cut out on the lines, and then we're gonna fit it into the left side of your interactive notebook. So the border around, here, let me help you. So if this was my paper, I'm going to cut along this line, this line, and then the top. Okay, so you should have one big strip. Remember, if you need scissors, there are scissors in the drawer over here by Cody. Are you going to call it 3 models of multiplication? It's at the top of the paper, so go ahead and write that in the front of your notebook. So you can write it at the top of the paper. It's on the top of your paper, the 3 models of multiplication. Okay. Now sit down with them and cut off sticks. you're going to put this on the notes side. Or you're going to put it on the left side. I want to be on the left side of the notebook. And then in your table of contents, you're going to put 3 models of multiplication. Because I kind of wrote the title on the top of it, so you don't have to write that on the actual page. And then the table of contents with the 3 models of multiplication. Okay, then when you have that glued in your notebook, put everything down and then eyes on me so that way I know you're ready for the next step. On the left side. Good, you can go to the bottom a little bit so it fits a little better. Remember, don't throw the paper in the trash can, walk it over. Okay, class.
Yes.
Okay, I'm going to wait till everyone's paying attention. Go ahead and keep putting it in your notebook if it's not in there yet. You need blue stick? Okay, just ask. There you go. Here. Turn around. Thank you. Okay, so on our interactive notes, who is the first person at the top? So, who do I have as the first person at the top? Ima. Okay, so on here, we're going to just look at Imas for right now. So with your table, what I want you to do is I want to look at Imas, and I want you to see if you can understand how Ima solved that problem. Okay, so you can work as a group, do it quietly, but work as a group, and I want you to see and try and figure out how Ima solved this problem. And then if you need to read the problem again, it's on the board. You can make notes and write on it. Go ahead and make notes and write on it. And then I want you to actually, on the blank, I want you to see if you understand and know this model, go ahead and write the name in the blank. If not, we'll fill it in as a class afterwards.
What is it?
Bless you.
Yeah, square model.
How do you do square
So see if you
Yeah,
can
I
figure
forget
out
how
how
to.
to solve
No,
it.
all I know is it's called square model.
I remember we learned
No, I
this
just
like
want you to see.
early
You don't
fourth
throw the
grade.
book. I want you to do it for us.
Forget how to do it though.
Hey, wait, let me just check
No, she solves it for you. See, they
I
all
meant to say 41 is 5. And then to the 6 foot, and then the next one, I think it should be 6 plus 1, and that's 7. And then 5 1 is 5.
I think she multiplied once. You said she added like a lot.
She got this answer. So they all got the same. So they got the same answer for grade 1. How many do you need? And
Remember, we're just looking at IMAs right now.
This, so it's 20
We're not
plus
looking at
30.
the other models, just
I
IMAs.
know, but I'm going like crazy. So this one, I think she used like division. How she cut up the boxes.
I think she used more multiplication
But how did you get the numbers on the outside?
because the number's really big like that.
Yeah, 575 pumpkins.
So I feel like she multiplied these numbers by one of these.
No, this isn't traditional. This is actual.
So do any of you know the name of this method? Has anybody ever seen it before? Addie, have you ever seen it before?
I've seen it before, but I've never done it. But I never I don't know the name of it.
Where are the factors in that diagram? Look at the first problem. What are the two factors that are being multiplied?
We'll see, but I want you to work. Don't prove it.
It's the same problem all three times, right? So what are the two factors in the problem?
Oh, 23 and 25.
Yeah, so that's sort of interesting. Where are they written in the first model? On the outside of the... So if the factors are on the outside of the box, what do you think's on the inside of the box?
You're multiplying those numbers to get that number that's inside the box.
Test it and see. Does that work?
Yeah. 5 times 2 is 10. 3 times 2 is 6. 3 times 2 is 6, and 2 times 5 is 10. And 3 times 5 is 15.
Wait, but how'd they get that 4?
2 and 2 is 4.
Yeah.
2 times 2 is 4.
Yeah, but where's the other? So they did this times that.
But then
Yeah.
how they get the 1?
The 1, that would be the 10th place here. So see, like 2 times 5 times 2.
Oh, 1
Yes.
and 0. Yeah.
Okay, so who has some insight or who thinks we kind of understand a little bit how we work this problem out? Well, first of all, let's see, do you like this model so far? Do you like this model? Is it a little confusing? No? Okay. All right, Layla, how does this model work?
They multiply the factors on the outside of the box, and then in the inside of the box, they put what it equals.
So in this box. so
Say
what
that
you're
again
saying-
really loud. I don't think everybody heard it because it was really important. So
Okay. So the factors are on the outside of the box, and they multiplied them by each other, and the answers inside the box.
Yeah, so let me do it up here for you guys. So what you're saying, if I can get a switch over.
yeah, it takes forever, Mr. Medford.
This is the final call for any class that needs to attend the fire assembly that's in the cafeteria, going to start in 1 minute.
There we go. Okay, so what you're saying is they take the factors on the outside. So they take, say, the 2 and 3, right? The 2 and 3. They take the factors on the outside and they multiply them by each other to get the factors inside the square. So why do I have 2 spots in the square? Evan?
To show the 10's place and the 1's place.
So the 10's place is where in the square?
The upper left corner.
Okay, so the 10's place is on top.
Yeah.
Okay, so 10's place is on top. And then, so you're saying the bottom of the square
Is
is
the 1's place.
the 1's place. Okay, so if I go 2 times 3, I get 6. And then if I go 2 times 2, I get 4. But then, so I go 3 times 5 next for the bottom right square, which would give me the 15, right? I
Yeah,
get
the 15.
And then what would I do next?
The 2 times 5,
2 times 5 gives me,
10.
there we go, 4. Now what do I do next?
The 2 times 2, to get 4.
Yeah, 2 times 2, we did that one last. So 2 times 2 gives us 4 in that box. But what do we do after we have all the boxes filled? Malin.
You cut the boxes in half, but it's in the 1 space, and then to the lines, you add them up.
So I would add up, well 5 is by himself, so it'd just be 5. So I add up this to get this number. And then what do I do in here?
You add 6 plus 1 plus 8.
Wow. So that gives us our 10s, and then what about this one? Okay, so we then multiply, add these together to get the 5, but then in the thousands place, we have nothing, right? We have nothing. Well, that's a pretty cool model. Did anybody come up with the name for the model? What do you think the name was in the model? Michaela. The square model, that's good because it uses a square, right? But what if we had 3 digits by 3 digits? Would it still be a square?
Be cute.
It'd be more of a rectangle maybe, but it'd be a larger square.
Maybe if you had 3 by 2,
3 by 2,
that'd be a rectangle for sure, yeah. A box
so
model?
The actual name for this one is, you can call it a box model, but the actual name is called a lattice model. A lattice model. I hope I spoke correctly.
Has anybody seen the model before?
Have you seen this model?
Yeah. Did anybody actually use this model previously? So we have a few kids.
Yeah.
The box model, the
Yeah.
lattice model. Good.
Yeah, she skipped it for us.
So
Ah.
that's one model. So now let's look at Thelma. So Thelma's the middle one. Let's look at Thelma's work. So we see that all 3 of them got the same answer, right? But now we're going to check out Thelma's work. Okay, so now I want you as a table, I want you to see if you can understand what Thelma did, and then see if you can come up with a name for the model. So as we work as a group, and see if you can understand what Thelma did.
So it looks like
She did 3 times multiply this, and then she added a few times together.
Say that again, Eddie.
She multiplied the 2 top numbers, and then she added all the answers that she got by multiplying these together.
so she is multiplying, but so yeah, she's doing this multiplying except instead of multiplying and giving the answer, she is adding up what she got to get an answer.
So look at these numbers.
Can you say that again, John?
I just want to know how these come in play.
Ask that. Let me zoom in on it and say what you're asking about again.
I want to know how that comes in play with the answer.
So everybody talk about that for a second. John's asking about the 20 plus 3 and the 20 plus 5. Any ideas on where those came into play?
I think I know where the 20 came from the 2 because the value on it, if this was in there would be a 0 there. So it would be 20. And then the 5 is in the 1 place, so it would be 1.
So they split apart the factors, it looks like? Is that what you're thinking? That makes sense. How does that work with the products, though? How'd they get 15? Anybody know how they got the 15?
Multiplied 5 times 3.
Okay. Say that again, Annie.
Multiplied 5 times 3.
Okay. And then what about the 100? Where'd that come from?
Multiplied 5 times 20. The number that's on the right side, when you're multiplying both numbers, you just turn this to a 0. And then you multiply it.
Yeah, they're just multiplying the numbers, but they're sort of expanding it out.
So like expanded form, which we just finished, right? Okay, that's cool. So does that work then with 60? Where'd the 60 come from?
20 times 3.
20 times 30. And then the 400 would be what?
20 times 20.
20 times 20.
Yeah, they're expanding it so you can understand it better.
Have you seen this model before, anybody?
Yeah.
What did you call it, Addie? Did it have a name? You remember it? Yeah, how many learned this one in 4th grade? You saw this one in 4th. It looks a little familiar, Layla. You're like, I see, yeah. Well, it's sort of weird. They're sort of partially modeling each one, right?
Yeah.
Okay, so it seems like a lot of you are coming to a lot of assumptions, okay? So let's see how we're doing. So, who wants to walk me through this problem and see how they found this problem? Let's go with Elena. So where did she start? Where did Thelma start in this problem?
5 times 3.
5 times 3. So she multiplied 5 times 3, which gave her 15.
And then she did 15 times 2, or 5 times 20.
5 times 20.
And
So we know 5 times 20 is 100. What's an easy way to multiply 5 times 20? Grace? 5 times 2 and add a 0, right? If you get 10 and you add the 0, it gives you 100. So we have 100, so 5 times 20 gives us 100. What step is next one?
we did 20 times 3.
20 times 3, which gave us 60. And then the last step for adding,
20 times 20.
20 times 20.
And she got 400, and then you added 11 to 575.
So what's something key in this one, in this model? What's something key that you want to look for that is really important because it could mess up your numbers? What's something you want to make sure you do while writing out this problem? Luke?
Multiply the tens place too. You can't just do 5 times 2. You need to do 5 times 2.
Yeah, you definitely have to multiply each number to make sure you multiply each number by all the numbers in the problem. But what's something when I'm setting up the problem or I'm writing down each answer, what do I want to make sure I'm doing? Mallory? Lining up the numbers, right? Because sometimes, because I have 4 different things I have to add up here, it can kind of get confusing. So I want to make sure I line up all 4 of my 1s, all 4 of my 10s, and then my hundreds place, right? Or I could make a big mistake and then get the wrong answer even though I had it all worked out. Okay, so for the 1s place, what does she do for the 1s? Adding them. When?
You add 5 with 0, 0, 0, and then 5.
Yep, 5. She gave us 5.
And then 6 plus 1 plus 0 plus 0 is 7, so you got 7 for the 10s. Then you got 4 plus 1 equals 5 for the 100s.
Right, so look at that. She got the same answer as Ima did, but she did it in a different way. See, there's multiple ways so far. We're going to look at one more after this, but let's come up with the name first. Does anybody know the name of this model? Let's go with Nick. Partial products, right? Because you have to break it up in each way for partial products.
How many had seen that model before? Oh, wow. How many had actually used that model to multiply before? Wow, Mr. Redford, yeah, a lot. That's exciting. It's exciting. We've shown them one that they didn't see, then one reviewed one they knew. So cool.
Okay, now let's go to Joe. We'll call him Joe Schmo. Okay, Joe did it this way. So now with your group, what I want you to do is I want you to look at how Joe solved the problem and look at each step. And then see if you can know the model name for this one. So work in your groups.
Instead of it looks like they added this one. Instead of adding, it looks like they just multiplied it. So they did the normal partial. Wait, no. So it looks like they did for to get the 400. They did 20 times, I think 20 times 20, or add a couple of zeros maybe. Oh wait, but she didn't.
Tell me about what you said about the 0 thing again,
The
Evan.
0, like 20 times 20, I'll take the 2 zeros from the 20s and add it onto the 4.
Oh, so maybe that's has something to do with the place value on the 460? Is that what you're thinking?
Yeah, so you would just do 2 times 2, and 2 times 2, they get 400, and add the 0 from it.
Where'd they get the 60 though in the 460? What do you think, John?
2 times
What say again?
2 times 3.
2 times 3.
2 times 3 plus the other 0.
Now, are they really multiplying 2 times 3, or are they
20 times 3.
say that again? They're really multiplying 20 times 3, or 2 times 3 plus the 0. Oh, that's sort of interesting. What about the 115? Where did the 5 come from?
5 came. Huh, wait.
From 5 times 3.
Say it again, John.
5 times 3.
5 times the 3 would be 15.
Yeah. But they put the one place in the 10.
Oh, I see. Then they moved over and did what next? It looks like the 5 times the what?
20.
5 times the 20, which would be 100, but they had some to add.
Yeah.
Got it. Interesting. Do you guys need to go meet?
I'll finish up this.
I was say I can take over if you need to.
I'll finish up this and do this.
Okay, good. That sounds good. Wow, I had great conversation here.
Great conversation in the whole
Mr.
class.
Maverick, this has been great conversation on every single one of these. I just gotta say, there's some serious detectives in here. You can tell these kids like math.
Call you private eyes.
That's right.
Yeah.
Say that, John?
I think the name would be the shortcut.
The shortcut. Yeah, it's like a shortcut method. Yeah.
Okay. Now
I
let's
like
come
that.
back
Make sure
together,
you
take
share that,
class.
Mr. Mefford.
Okay, now let's finish up these notes. So, who wants to work me through this one? Who wants to work me through this one? Let's go with Nick. So 5 times 3, which gives us, okay, carry the 1. Maybe what he did was crossed off in the next round. Okay, so carry the 1.
Then you do 5 times 2 plus that 1 that you carried.
Okay, which gives us 11.
So then you put your 11 down next to the 5, which is 115.
Okay, now what's next after that?
Then you do put your 0 down.
Put the 0 down. How come I had a 0? Can anyone tell me why I added a 0 there? John.
Because you already used the one place.
Right, so that's representing the ones place, so now I have to go to the tens place, right? There you go. So, man, looks like Joe knows what he's doing. Okay, so next step,
You do 2 times 2.
2 times,
Yeah.
2 times 2? Remember, you used the 1, so we have the 5 down. Now we're on to the 2, but where do you have to go first? Look where Joe went first. Remember, what number is here?
You do 2 times 3.
2 times 3, right? You can't forget about the ones place on top. So you have to go 2 times 3, which gave us
6.
6. Okay, and then that's, I think that's where Joe crossed off the 1 because he doesn't need it anymore.
And then you do 2 times 2.
2 times 2, which gave us
4, 6, and then you just add it.
right. So then we just add them. So I see 3 different models, and I see 3 of the same answer. But what is the name of the last model?
I love Johnny's name. It's a great name for this model.
All right, Johnny, what's the name?
Shortcut?
Shortcut. There we
I
go.
love it.
Shortcut is a great name. So the shortcut model.
And why is it a shortcut, John? Because he's not doing what? What's Joe not doing that Thelma did?
He's not adding. He's not putting all the numbers down.
Yeah, he's sort of shortcutting it and just writing what the represent. Ah, that's interesting. Is that the official name, Mr. Mefford? I love that
National
name.
name for it. They might see in the textbook. Let's go with Aaron. I think he's gonna jump out of his seat. Traditional, right? The traditional algorithm. Well, we're just gonna put traditional on it. Are you okay now? You got it out? Okay. Right, the traditional model. Okay, so now we have all 3 steps. They have all 3 of the same answers. So now what I want you to do is I want you to look at all 3 as a whole, okay? And then in your groups, I want you to compare some similarities and some differences between the 3 models. So work in your team, and I want you to come up with, let's come up with 2 similarities and 2 differences for each one.